Okay. May, June 2020, paper 1, variant 2. Yeah. Question 1. 5 athletes, PQRS and T complete a race. We have a table. Which statement is correct? Which statement about the athletes is correct? Which athlete won the race? This is quite easy. The athlete with the shortest timing should win the race, definitely. So athlete P won the race. Okay, he had or she had the shortest time and was ahead by how many seconds of the athlete in the second place? The athlete in the second place was probably athlete uh, Q or T, I'm sorry. Okay, so athlete P was the first and athlete T was the second. And the difference, the time difference between them was 0.70 seconds. How did I find that? I just subtracted 2, 23.2 minus 22.50. So the answer would be A. This is quite easy. Moving on. Okay. Question 2. The graph shows how the speed of an object varies with time. At which labeled time is the acceleration the greatest? The acceleration has to do with what? The acceleration in this question has to do with the slope, definitely. Okay, so the slope, which slope was the greatest slope? Which slope or which portion of this graph had the greatest slope? Yes, definitely it was A, definitely A, not D. Okay, I know a lot of you want to say D. Okay, and I know a lot of you want to say D, but actually the right answer would be A. Why? Because A is the greatest slope. It doesn't have to do with how long the graph is. No, it doesn't have to do with how long the line is. It has to do with how steep the line is. Okay, so it is definitely A. Question 3. Which statement about acceleration is correct? Hmm, It's related to the changing speed of an object. Okay. Its distance. No, no, I don't think acceleration has to do with distance. It's the force acting on object divided by the distance. I don't think so. It's the force acting on object. No, definitely not. So it would also be A. Yes, I know we have 3 A's in a row, which is okay. Which is definitely okay. It is definitely related to the changing speed of an object. Hmm. Question 4. Which statement about P and Q is correct? P and Q, they were both hanged from 2 springs, okay, identical springs. Hmm. The reading on the springs are now different. They have different volumes, or do they have equal volumes? I think they have equal volumes. How would I know if they have equal volumes or not? They have the same shape. So they do have the same volume, but different weights. Yes, different weights. Q had a reading of 3 newtons, but P had a reading of only 2 newtons. Okay, they do have, well, different weights. Hmm. Any questions? Okay. Um, a space probe is taken from Earth to Mars. The force of gravity on the surface of Mars is less than the force of gravity on Earth. How do the weight and the mass differ? How are the weight and the mass different? Does the mass change when an object moves from Earth to Mars or from Earth to any other planet? No, the mass definitely doesn't change unless, for example, you decide to lose some weight while traveling from Earth to Mars. That's the only case in which the mass might differ. But other than that, the mass would not differ. So the mass would definitely be unchanged while going to Mars. But the weight, the force of gravity on Mars is less. When the force of gravity is less, then the weight would also be less. The weight would decrease. W equals mg. Weight equals mass times the gravitational acceleration. Okay. So on Mars, it's 9.8, it's less than 9.8. Okay. Water has a density of 1,000 kilograms per meter cubed. A rectangle swimming pool has an average depth of 1.6. The length of the pool is 25. The width of the pool is 10 meters. What is the mass of the water in the swimming pool? How can I find the mass? We only have one equation. We only have one equation. Yeah. Density equals mass over volume. If you want the mass, then the mass equals density times volume. We have the density 1000 times the volume. In this case would be just multiplying the length times width times the height. 25 times 10 times 1.6. Okay. And this would give a total mass of, I guess, 400,000 kilograms. Yes. Yes, the mass of water in a swimming pool would be huge. Okay. Hmm. An extension time graph, extension load graph of a spring. An empty can of weight 3 newtons is suspended from the spring. Liquid is poured into the can until the extension is 8 centimeters. Okay. An empty can of weight 3 newtons is suspended from the spring. Okay. I need you to actually read this question quite carefully. The empty weight is 3 newtons. When liquid is poured into the can until the extension is now 8 centimeters. Where's an extension of 8 centimeters? This is an extension of 8 centimeters. What is the weight of the liquid? You need to draw a horizontal line from 8 centimeters and then until you reach the graph, okay, until you reach the line, a vertical line. Should the load be 16 newtons? Should the weight of this liquid be 16 newtons? No. Why? Because there was an empty weight of the can. You need to subtract the empty weight of the can. The total weight, okay, what is 16? You need to understand what is 16. 16 is the weight, okay, of the liquid plus the can. We need the liquid of the can. We need the liquid of the we need the weight of the liquid alone. So to find the weight of the liquid alone, you need to subtract. Okay, 16 minus 3 would be 13. So 16 minus 3 newtons would be 13 newtons. Okay. What is meant by the moment of a force of an object? Moment. Moment has to do with the turning effect. Okay. The turning effect, the magnitude of the force, no, direction of the force, the time for which, no, it's the turning effect. Which energy source is not renewable? Which energy source is not renewable? Nuclear fission. Nuclear fission in the nuclear reactors when we split the uranium. Okay. Not renewable. Two motors X and Y lift loads of the same weight through the same vertical distance. Same weight, okay, and same vertical distance. Um, Motor X is more efficient than motor Y. Motor X is more efficient than motor Y. Which statement about, okay, which statement about the motors is correct? When motor X is more efficient than motor Y. This is actually a rather difficult question, to be very honest. Okay, this question is quite difficult. Why is it quite difficult? Because to understand efficiency, we need to um, think about it as the more efficient object, okay, and or the more efficient motor would waste less energy. The more efficient motor would waste less energy. But in this case, the same weight, okay, is lifted through the same vertical distance. So this is the same energy output. This is the same energy output. For motor X to be more efficient in this case, for motor X to be more efficient in this case, the energy input of X has to be smaller than that of Y. The energy input of X has to be less than that of Y. Why? Because in this case, X has, let's say, energy input, let's say 100 joules, okay? And Y has an energy input of 120 joules. Okay, 120 joules. If X is more efficient, okay, you need to understand that, for example, the energy output, the work done, this is the work done. For example, that the work done was 80 joules, okay, in both motors, the work done was 80 joules. So if motor X has an input of 100 joules and an output of 80 joules, while motor Y has an input of 120 joules and an output of 80 joules. From this, we can see that actually X has only wasted, okay, it wasted only 20 joules, while Y wasted 40 joules. So yes, definitely, this means that X is more efficient than Y. Okay? X in this case is more efficient than Y. Okay? Okay. Hmm. A man can either take the escalator or the lift. Okay? Either an escalator or a lift. The escalator takes 20 seconds. The escalator takes 20 seconds to carry the man between the two floors. Okay. The useful work done against gravity is W. Okay. And the power is P. We're talking about what? We're talking about the escalator. Okay. It takes 20 seconds. The time is 20 seconds. 20 seconds. The work done is W, whatever. Okay, it's W, work done. And the power is P. Now the lift takes 30 seconds. The lift takes time is now 30 seconds. We need to find the power and the work done by the lift. Work done equals what? Work done equals force times distance. Force times the distance moved. Force times the distance moved means I'm lifting the same man. صح. The escalator and the lift, they are lifting the same man. So he has the same force, the same weight, same force or the same weight, moving up two floors, the same two floors. So the same distance. In both cases, in the escalator and the lift, the man or the escalator and the lift would both do the same work done on the man. Both of them would have the same work done. Why? Because they both lifted the same man, they did the same work done, okay? They did the same force, they applied the same force over the same distance. Force times distance. So the same work done. What about the power? Power equals work done over time. And we know that the power is inversely proportional. Okay, it's inversely proportional to what? Huh? It's inversely proportional to the time. As the time increases, what happens to the power? As the time increases, what happens to the power? The power decreases. So the useful power done by the lift is less than P. Why is it less than P? Because the time taken by the lift was less than the escalator. That's it. When you increase the time, what happens to the power? The power decreases. Okay? Okay. Hmm. Diagram shows a solid block. Which labeled surface should the block rest to produce the smallest pressure? We need the smallest pressure. To decrease the pressure, what should you do to the area? We need to increase the area, the smallest pressure. Okay? Smallest pressure is the largest area. The largest area, okay, would be P, not R. P and R don't have the same area. P is 80 times 40, while R is 80 times 20. There is a huge difference, okay? So definitely, okay, definitely this question would be P, okay? Question 11 was C. Hmm. A beaker contains a liquid. Beaker contains a liquid. On what does the liquid pressure at position X depend? Liquid depends on the pressure in any liquid. Pressure in any liquid depends on two things. Depends on two things. What are they? The density and the depth. The density of the liquid and the depth of X below the surface. And that's it. As you increase the density, the pressure increases. As you increase the depth below the surface, the pressure increases as well. Okay. Yeah. Evaporation occurs on from the surface of a pool of water. Which statement describes the change of state? Electrons, molecules that move from the liquid have the same energy. The more energetic molecules escape the liquid. Yes, we know that the more energetic molecules escape from the surface, leaving behind the least energetic molecules. A gas in a sealed container is compressed. Yep. Gas in a sealed container is compressed slowly so that the temperature does not change. What happens to the molecules of the gas as a result of this compression? When you compress a gas, okay, when you compress a gas at a constant temperature, as you decrease the volume, okay, compress the gas means that the volume decreases. Hmm. The volume is now decreasing. What happens to the pressure? The average speed of the molecules increases? No. Why? Because the temperature does not change. The average force in a collision between a molecule and the container increases. There are more frequent collisions between the molecules in the container. Which one could be correct? The volume of each molecule decreases. This is definitely wrong. Okay, so A and D are definitely wrong. The average force in a collision between a molecule and the container increases. For the force to increase, this requires the molecule to move at a faster speed. And we know for a fact that the speed does not change. Why? Because the temperature is the same, so the kinetic energy is also the same. So the average force will not increase. No. Okay. The molecules will hit the walls more frequently because the surface area of the walls has now decreased. Okay. Surface area has decreased. This is a thermometer. This question has been cancelled, but to know the answer quite quickly, the temperature difference between the two fixed points, you actually are required to know the fixed points of a thermometer, which are 0 and 100. Okay, you are required to know them. 0 degrees the melting point and 100 degrees the boiling point. So the difference between them would be 100 degrees Celsius. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into a warm surrounding. Which statement about the metal block is correct in the morning? Which statement about the metal block is correct in the morning? As it moves into a warm surrounding, what happens? The internal energy of the metal block increases, the temperature of the metal block decreases, convection, the metal block contracts. No, it doesn't contract. Okay, convection, no. Through the metal block, no, it's wrong. The temperature decreases, it's definitely A. Why? Because the temperature has increased. Hmm. We have some blocks. The same quantity of thermal energy is given to each block. Each block has received the same amount of thermal energy. Which block shows the greatest rise in temperature? The same amount of energy. All of them, for example, would receive 1,000 joules of energy. Which of them will have the highest temperature? Which of them would increase its temperature to the highest point? Definitely, it would be A. Yes, thank you. Why is it A? Hmm, Because it's the smallest mass, it's the smallest object. So if you give a small object a high amount of energy, it would increase its temperature to the highest point. Okay. Hmm. Okay. Question 19. Which diagram and reason explain the heating of the room by convection? This is a radiator. This is a heater. Okay. And we all know that in a radiator or in a heater, what happens to the hot air molecules? What happens to the hot air above the heater due to convection? Hot air due to convection. What happens to the hot air? It moves upwards. Moves upwards. So why is wrong? So it's diagram X. Air density decreases or does it increase? We know that it decreases. Okay. Air density decreases and it moves upwards. Okay. Why is wrong? Why? Because hmm, the air does not move towards the heater. No, it moves away from the heater or it moves upwards because the density decreases. Okay. Hmm. Two thermometers are placed in direct sunlight. The bulb of thermometer P is painted white, Q is painted black. How and why would the thermometer readings differ? We have a white thermometer and we have a black thermometer. P would read higher than Q or less or lower than Q. P is white and Q is black, so I think that thermometer Q would be higher. So P would be lower than Q. Why would P be lower than Q? Because black is a good absorber, or is it a poor absorber? I think as well that P that black is a good absorber of radiation. We have a wave, the amplitude and the wavelength. We know that the amplitude is 3. Again, the amplitude is 3. This is the amplitude, and the wavelength is from crest to a crest. So this would be the wavelength. Amplitude 3 and wavelength is 8. Hmm, It's quite an easy question. Question 22. Waves travel more quickly. Okay. When the water is deep, waves travel more quickly on the surface of water when the water is deep. A stone is dropped at point X in a varying depth. Which region is the deepest? Which region, A, B, C, or D, is the deepest? This is a really interesting question. Which region would be the deepest? It would be C. Why would it be C? Because as the water gets deeper, okay, as the water gets deeper, what happens to the wavelength? What happens to the wavelength? The wavelength increases as the water gets shallower. Okay, the wavelength decreases. So when he asks about the deepest point would be point C. Why? Because it has the longest wavelength. Okay, the longest wavelength. Any questions? Okay, question 23. The ray of light is partially reflected back into the air and partially refracted into the glass block. Which rows identify the angles of reflection and angles of, or the angle of refraction? Angle of reflection and angle of refraction. Reflection would definitely be 1, and refraction would be 4. Okay, the angle of refraction or any angle, angle of incidence, angle of reflection, angle of refraction, whatever angle, this angle has to be between the ray and the normal line. It has to be between the ray and the normal line. So definitely the answer would be B. Yes. A beam of light consists of yellow, blue, and yellow and blue light. Which diagram is correct? Which diagram is correct? The rays never refract upwards in a prism. Okay, they never refract upwards. So would it be C or would it be D? We know Gebiv. Roy Gebiv. Yellow has to be above blue. Yellow has to be above blue. So it would be D. Okay, Roy Gebiv. An intruder alarm. Which type of electromagnetic wave does the sensor detect? Okay, intruder alarms use the yes, we know it. Infrared radiation. Infrared radiation. A dolphin sends out a wave. An echo returns 0.01 seconds later from a fish which is 7.5 meters away from the dolphin. What is the speed of the sound in water? What's the speed of the sound in water? How can I calculate the speed of sound in water, especially when it has to do with hmm, an echo? An echo, we know how to calculate the speed. Speed equals 2 distance over time. 2 distance over time. Why 2 times d? Because the wave moves all the way to the fish, for example, in this case, it moves all the way to the fish and then back. Okay? Moves all the way to the fish and then back. So 2d times 2d over t. 2 times 7.5 over 0.01. I guess the answer would be D. Okay. Yeah. Which diagram shows the magnetic field between the poles? Which diagram shows the magnetic field uh, between the poles? Definitely, it would be A, north to south, north to south. This is an easy question. Yeah. Okay, good. Question 28. Four nails A, B, C, and D are tested to find which makes the strongest permanent magnet. One of the nails is placed against the bar magnet. The bar magnet is then removed and the number of paper clips remaining attached to the nail is recorded. Each nail is tested individually. Which nail becomes the strongest permanent magnet? Okay. Which nail becomes the strongest permanent magnet? Someone said C. Yes, actually, it is C. Why is it C? Hmm. Why is it C? Because it retains the most, it keeps the most amount of nails attached. For example, nail A, for example, it had two nails attached initially, and then it had no nails attached when it was removed, when the bar magnet was removed. So it's wrong. B, it had two nails attached, but then when we removed the bar magnet, only one nail remained attached. So this is, يعني, let's say 50%. For example, it's one out of two, one out of two, which is 50%. So this is a bit weak. In this case, C, three out of four, okay, would be around 75%. This is much stronger. D, it would be 2 out of 5, which is only 40%. So it's much weaker. That's why C is the strongest permanent magnet. Okay. Yeah. A cloth is used to rub an uncharged plastic rod. Both the rod and the both the rod and the cloth become charged. Why does the plastic rod become negatively charged? Yes, we know this. Negatively charged. The rod becomes negatively charged. Why? Because it gains, yes, electrons. Yes, it gains electrons. And the cloth gains positive charge. The rod gains electrons and the cloth loses electrons. Yes. It's all about the matter. It's all about gaining and losing electrons. Gaining and losing electrons. Hmm. Yeah. The wire between P and Q can be removed and replaced by a circuit component. Where should the voltmeter be connected to measure the potential difference across the lamp? Where should a voltmeter be connected to measure what the potential difference between of the lamp between R and S? A voltmeter between R and S. That's quite easy. Hmm. Ah, this is I like this question. The voltmeter reading is 2.2 volts. 2.2 volts. And the meter reading is 0.25 amperes. What's the resistance of each resistor? R equals V over I. V is 2.2 divided by 0.25. So the total resistance would be 8.8 ohms. Most of you would just choose D, which is wrong. Why? Why is D wrong? Because this is the resistance of both resistors together. This is the resistance of both of them together. So simply you need to divide by 2 and each resistor would have resistance of 4.4 ohms. Okay? One lamp is removed and two other lamps go out. Okay? one lamp is removed and only two other lamps go out. If you remove, let's say, lamp L, let's say if you remove lamp L, what will happen? All of the other lamps will actually go out. All of the other lamps would go out. So it's not L. If you remove lamp M, what would happen? Nothing would happen. Only lamp M would go out. Why? Because it's on its own. It's on its own branch, so it doesn't affect any other lamps. Lamp M would not affect any other lamps. If you remove K or N, if you remove K or N, what would happen? Again, nothing would happen if you remove K or N. But if you remove J, let's remove J. What would happen if I remove J? Both K and N would go out, but L and M would not be affected. Okay, L and M would not be affected. If you remove, again, if you now remove lamp J, what would happen? K and N would not have any current. The current cannot pass through, this was the current. It cannot pass through J now. Why? Because you have removed J. So K and M would be switched off. So lamp J is the one which would affect two other lamps. We have a diagram. The temperature of the surroundings increases. The temperature increases. What will happen to the brightness of the lamp? When the temperature, okay, when the temperature increases, what happens to the resistance? What happens to the resistance of the thermistor? The thermistor resistance decreases. So the voltage decreases. If the voltage of the thermistor decreases, what happens to the voltage of the lamp? The voltage of the lamp increases. When the voltage of the lamp increases, what happens to the brightness of the lamp? The brightness of the lamp. What happens to the brightness? The brightness as well increases. So it will be brighter. Okay? It all has to do with the thermistor. When the temperature increases, again, the resistance decreases. When the resistance decreases, the voltage decreases. When the voltage decreases, the voltage of the lamp increases. Yeah, the voltage of the lamp, when it increases, the brightness also increases. Okay? A student constructs four circuits, each containing a fuse. The fuse blows in one circuit and both lamps in the circuit go out. The fuse blows up and both lamps go out. Okay? Someone has a problem with the previous question. Okay. Again, this is a thermistor. Okay? Very quickly. This is a thermistor. How does the thermistor work? What's the method of operation of the thermistor? The temperature and resistance are inversely proportional. Are inversely, okay, proportional. When the temperature increases, the resistance decreases and the voltage decreases. Again, for example, this is a battery. This has a voltage of, let's say, 12 volts. Initially, this had 6 volts and this had a potential difference of 6 volts initially. When the temperature increases, we know that the resistance decreases. So when the resistance decreases, the voltage decreases. So it wouldn't be 6 volts. This would have a potential difference of 3 volts. When the thermistor has a potential difference of 3 volts, the lamp would now have a potential difference of 9 volts. Why? Because the total voltage has to remain constant. The total voltage has to be 12 volts. Okay, the total voltage has to be 12 volts. When the total voltage is 12 volts, خلاص يبقى when the voltage decreases in the thermistor, the voltage increases in the lamp. When the voltage increases in the lamp, the brightness increases as well. Okay, again, back to question 34. When the fuse blows out, both lamps go out as well. Which in which circuit would the fuse affect both lamps? Definitely not B. Why? Because B would affect only this lamp, and definitely not C because in C the fuse would affect this lamp only, and definitely not A because the fuse would do nothing in this case. It would literally do nothing in this case. So the only question or the only answer would be D. When the fuse goes out, both lamps would Okay, when the fuse blows up, both lamps would go out in this case. We have three voltage time graphs, which graph shows an alternating voltage. All of you would say P. Yes, I know. All of you would say P. What about Q? Is Q an alternating voltage or an alternating current? Yes. Why? Because it was negative, it increased to a positive value, and then it's moving to a negative value, and then it's increased to a positive value. Okay, so it keeps on alternating, it keeps on changing between positive and negative values. R is also an alternating. Why? Because it keeps on changing, it keeps on alternating between negative and positive values. So P, Q, and R are all alternating voltages or alternating currents. Okay? Okay. Transformer. Which statement about the transformer is correct? Which statement about the transformer is correct? It can operate from a 12-volt battery. Can a transformer ever, okay, can a transformer ever operate from a battery? No. Why? Because the battery is DC output, a direct current output. And we know for a fact that a transformer has to have an alternating current input and output. Okay. You cannot operate a transformer from a, okay, you cannot operate a transformer from a DC output. Never. Okay. That's definitely wrong. It has a core made of steel. No, we know that the core is made of iron. It steps the input by a factor of 1,000, or it steps the input down by a factor of 1,000. Is it a step up or a step down transformer? This is quite obvious. It was 40, it became 40,000, so it's a step up transformer by a factor of 1,000. Why is it a factor of 1,000? Because all you did was you multiplied. hmm, 40 times 1,000, it became 40,000. It's quite easy. What does a neutral atom of this nuclide contain? Contains 26 protons, 26 protons, and 26 electrons, and 30 neutrons. In a neutral, okay, neutral atom would have the same amount of protons as electrons. Which statement about the nuclei of all atoms is correct? All atoms. Okay. Which statement is correct? They all contain electrons. They are always stable. No. They all contains protons and electrons. No. They all have a positive charge. Yes. We're talking about what? The nuclei. We're talking about the nucleus of atoms. The nucleus of any atom would have a positive charge. Nucleus of any atom would have a positive charge. Okay? Hmm. A thin sheet of paper is placed between a radioactive source and a radiation detector. The count rate falls to a very low reading. From this result, which type of radiation is the source emitting? Definitely an alpha particle. Why? Because the paper, what does the paper do? It stops the alpha particles. It does not stop beta or gamma, and definitely not X-rays. Okay? A paper, a sheet of a thin sheet of paper, it could stop alpha particles. Mm. A radioactive isotope has a life of half-life of 120 minutes. It emits radiation at a rate of 100 particles per second. Half-life, 100 particles per second. How long does it take for the rate of emission to fall to 25 particles per second? Again, initially it had 100 particles per second. How long will it take for the radiation to reach 25 particles per second? That's quite easy. What do we do? 100 divided by 2 is what? 50. Then divide by 2 again is what? 25. What did we do? We just divided by 2 two times. We divided by 2 two times. What does this mean? It means that we have two half-lives. Two half-lives. Each half-life is 120 minutes. So two half-lives times 120 is 240 minutes. 240 40 minutes. Okay. Okay.